Well, hello and welcome to this NASA Earth Data webinar, short titled Downloading Data from the NASA Earthdata Cloud using the earthaccess Python library. This is going to be a fun one, and I'm really looking forward to it. We're passionate about sharing knowledge, and we're hopeful that you'll get something useful out of today's presentation. Just a few words before we begin. This is a webinar short, and as such, our goal is to maximize the use of your time today, and ours too. And that means there will not be a Q&A session. Feel free to use the chat, but there won't be a Q&A session. We're using our full time today for the presentation. So with that, I'm excited to turn it over to Mikala.
All right, well, let's get started. Hi, everyone. I'm Mikala Beig. I work at the National Snow and Ice Data Center in the User Services Group. Super excited to be here today to provide you with an introduction to the earthaccess Python library, which was developed in order to simplify programmatic access of data from the NASA Earthdata Cloud. So before the existence of earthaccess, if you wanted to access NASA Earth data programmatically, you needed to discover and then understand how to interact with a bunch of different APIs or application programming interfaces in front of independent systems, and you needed to learn how to format search terms for each of these. You had to understand how to store and send multiple types of credentials, both your Earthdata Login and AWS credentials. You needed separate workflows if you wanted to access data directly in the cloud by streaming it versus downloading it to your local machine. And you had to know a little bit about interacting with cloud-based object storage. So the motivation behind earthaccess is to help people who are interested in using NASA Earth data programmatically get to the fun part, the data analysis, a lot more quickly and easily. And earthaccess streamlines all of that previous complexity down to just a few lines of code. So, all right. So just some resources. Um, the earthaccess documentation is the first link here on this slide. I really encourage you to take a look at that documentation, learn more about earthaccess here than just the brief intro you're going to get today. You can find a copy of the demo notebook that I'll be working in at this GitHub location here. And then just note, in order to access any NASA Earth data, you need to sign up for a NASA Earthdata Login account. So that's freely available to anyone, and you can sign up at the link there at the bottom of this slide. Today, I'm going to be working, I'm going to be doing a demo in a Jupyter notebook. It's Python based. I'm going to be working in my notebook in Jupyter Lab. You'll need Python 3.8 or higher and a handful of libraries. Most importantly, the latest release of earthaccess. You can head to that quick start guide that's linked on this slide and get some installation guidance there. I'm going to go ahead and turn my camera off for this part because I'm going to be typing on a different monitor and not looking at you. All right, so the purpose of this demo is to give you an introduction to using the earthaccess Python library to find and download data. So I'll be working on my laptop and downloading files locally to it. To download files from the NASA Earthdata Cloud, you don't need to be working within a cloud instance. So you can replicate this workflow with your own computer at home. I'm going to demonstrate a really simple workflow showcasing the core functions of earthaccess, which are authentication, search, and data access. Those are highlighted in red in this overview of steps, but I'll be showing a couple of bonus features as well. But I hope at the end you'll see that you can truly access data with just a few lines of code. All right, so we're going to jump into it. I'm going to be doing some, live coding, actual typing. this comes with challenges. You're going to see me make typos and stumble a little, but it kind of helps set the pace. And then some of the time for a couple of larger code blocks, I'm going to go ahead and execute a cell I already have pre-populated. But the first thing we need to do is import the libraries, most importantly, Earthaccess. I also use X-ray just briefly in an example and uh, hvplot to plot some data at the end, just to show how we can get into a file. hvplot can take just a minute to import. So while that is happening, I'm going to go ahead and start typing for my authentication steps. So we authenticate. We can do that with Earthaccess using Earthaccess Login. Okay, so we have our libraries. And it's going to prompt us to enter our Earthdata Login username and password. All right. So as soon as that goes, all right, so we are authenticated. So the next thing that I'm going to do is look for some data. I'm going to search for data sets using a keyword search. But just a side note before we get into that, I just want to mention while you can perform some data discovery and exploration using Earthaccess, the real power of Earthaccess is once you know the data set you are interested in, and you're needing to automate data access steps that you might need to repeat hundreds of times. But if you haven't yet discovered your data set of interest, it makes a lot of sense to do some data discovery and research first using resources like the NASA Earthdata website and the web application Earth Data Search. The NASA Earthdata website provides a lot of access to documentation, tools, educational resources, where you can learn about missions and associated data sets. Earthdata Search web application allows you to search through petabytes of NASA Earth data using a map interface and lots of powerful search capabilities. So, but to just give you a quick look at what data discovery could look like with Earthaccess, staying within the notebook, we are going to make a query for data sets using a keyword search. So when we use the search functionality in Earthaccess, we are querying against NASA's Common Metadata Repository, or CMR, in just the same way that an application like Earthdata Search is doing. So we are going to create a query object. We are going to use Earthaccess search data sets, and we are going to provide a keyword. I am going to use ISAT2. And we're going to ask for the length of that list that gets returned so we know how many data sets get returned in that query. And you can see I already had a typo. So Earthaccess goes out, queries against CMR through the CMR API, and finds 79 data sets that have the keyword ISAT2 associated with it. So what gets returned from our query is a list of dataset objects, and these dataset objects have a number of methods associated with them. We're going to use one of those, the get UMM method, to grab some information about the datasets. This is a longer code cell that I'm going to execute and not type all out. So I have it pre-populated here. And we don't want to overwhelm our display with a printout of metadata from 79 different data sets. So I've limited it to just printing out 5 of those here. And so some of the metadata that we're going to ask for, I'm going to ask for the long name or full long form name or title of the data set. Using entry title, I'm going to ask for the short name, which is an abbreviated name for the data set. I'm going to ask for a description of the data set, which I do by grabbing the abstract from the metadata. And then I'm also going to ask for the DOI. And the DOI is a digital object identifier for this data set. It's a unique identifier for data sets that specifies the data set and the particular version of that data set. So, all right. I'm just going to run that. We're going to print those out. So you can now browse through these data sets and read about what they contain, what parameters are measured and included. In this notebook here, if we scroll down a bit, I've included a list of some of the useful metadata elements that are available with that method, that get UMM method, in case you want to play around and access some of those. All right, so that was steps 1, 2, and 3 in our overview. We authenticated so we can access the data. We searched for data sets using a keyword search, and then we took a look at some useful metadata. So the next thing we're going to do is search within a particular data set that I'm going to choose, and we're going to search within that data set for particular files that satisfy some search criteria. So in this demo, I'm using ATL06, which is the ISAT2 land ice height product. We can see that appeared in our list up here. So we saw that Earthaccess has a method for searching for datasets called search datasets. It also has a method for searching for files or granules within a particular dataset called search data. So we're going to use search data, and we can apply various filters or search criteria to narrow down our results. In this particular example, I'm going to use a bounding box to search for land ice height data over the Juneau ice field in Alaska. And I'm going to restrict my search to data collected during March and April of 2020. All right, so we set up another query, much like we did before, this time using search data. In this case, I'm going to give it the DOI, so I can get that from our metadata printout up here. I'm going to provide some bounding box coordinates. In this case, they're formatted latitude and longitude corner points, formatted in this west, south, east, north order. I'm also going to give a temporal range to search within, and I'm going to grab that from up here. And that's our start and end date. And like we did before, I'm going to find out how many files get returned in this particular query. So we get 4 files in this case, depending on your spatial and temporal files and the data set you're looking at. That could be quite large. It just depends on the data you're working with. All right. So the next thing we're going to do, at this point, we're ready to actually download the data to our local machine. So to do that, I'm going to use Earthaccess download. And I'm going to give it the results from our search that we just did. And you can provide a path to a folder to Earthdata or to Earthaccess download. In this case, if you don't give it a path, the default behavior is that it will should create, yeah, there we go, a data folder in your working directory, and it'll put the files in there. All right, so that's the core functionality of Earthaccess. We've now downloaded data. I've downloaded data to my laptop, have it here, now I can work with it. I'm just going to show you a couple of more steps. They aren't Earthaccess, but I'm going to use Xarray to open a file and then plot a variable from within the file, just to kind of provide you an example of a jumping off point for some data analysis. So we're going to use the Xarray that we imported earlier and open one of our files. Oh, did I forget to give it an alias? I did. Okay, so I need to use the full name here. So Xarray goes, I've given it this, just one of the files from the 4 we downloaded. I'm pointing it to a particular group within the file, and I know about where I want to look in this file because during my data discovery and exploration process, I went to the dataset landing page, and there's a link to that here in the notebook. And I accessed the user guide and I read about this data set. So I know at this point that I'm interested in the land ice height variable, which is this h_li. So I'm going to go ahead, scroll down and just do a quick sample plot. Yeah, and that's it. So hopefully you can start to see the simplicity of using Earthaccess as part of your workflow to download data. Technically, you can get data with just 3 lines of code. Here is just a little bit of a recap of what we did here. We authenticated, we did a search, and we downloaded files. And that's it. I do want to pop back over here. So I just want to give some acknowledgments. The development and growth of Earthaccess wouldn't be possible without support from the NASA Openscapes program, which has a long history of doing science, software development, and especially teaching. So NASA Openscapes continues to support dozens of hands-on workshops where we teach not only open science practices to researchers, but it also provides us with a valuable framework where we learn alongside our user community. There are some other resources on here, like the NASA Earthdata Cloud cookbook. This was designed based on feedback from learning and responding to common questions and data analysis pain points. And NASA Openscapes, we continue to support and expand these resources. So please do take a look. Go to some of those links later. And then just finally, Earthaccess is not just a library, it is also a really welcoming community. Community of users, contributors, maintainers. The community hosts regular collaboration cafes every other week. Everyone is welcome. It's a great place for new users to come and find ways to get involved and expand their skills. And that is it. Thanks, everyone.
Thank you for walking through all of that with us, Mikala. Thanks to everybody who attended live, and the recording of this event will be available soon, as will related materials. You'll be able to find all that on the Earthdata website. And while you're there, be sure to check out all of our upcoming webinars and other freely available learning resources. We hope you'll join us again soon for another NASA Earthdata webinar.